Hello everyone, this is Dr. Lennon, and I wanted to take a look at the second Markowitz portfolio problem, where we're actually looking to, again, create a portfolio with the same options: foreign stock, intermediate term bond, large cap growth, large cap value, small cap growth, and small cap value. But now our goal is not to maximize return based on some variance in the different returns on investment, but we're trying to do it by minimizing the distance or the differences, minimizing the differences with this other metric of portfolio performance, the S&P 500, which I'm sure you've heard of. So the differences are essentially going to be the differences between the returns that we calculate in these years based on the percentage that we invest in each category and the S&P return in that given year. And each of those are squared. The reason they're squared is so that we're always getting positive values. We don't want, it's a common technique to minimize the squares of these sums. This is the same technique that's actually going on when we do our linear regression. It's sometimes also called least squares linear regression. So again, that's all we're doing when we're doing this, is we're copying these return values by year here. So for instance, if I wanted to look at the first one, I've got a return of 10.06%, 17.64 in bonds, 32.41, 32.36, small cap growth, 24.56, and small cap value 25.32. You might notice now there's one extra thing, but what are we doing? We're looking to have this be the distance. We want this to equal D1, the difference between the two. So what I do is I take all of those added together with the percentage weights from each category, and I want to subtract the S&P value 25. So I'm going to put a minus 25 in here. And you'll note that I'm going to check that, and it will work out. Oh, I copied the one wrong down here. Small cap growth is 33.44, 33.44, and 24.56. Must have been looking in the wrong place. So there we go. That all works out. And you just do the same for each of the categories. And again, you want all of your investments to be non-negative, so you'd select that greater than or equal to 0. All right, so now we want to see how do we choose our weights, our percentages that we're going to invest in each category, and minimize that function that is the square of each of the differences. Well, let me show you the spreadsheet that I've got set up. So this one right here. So this one is essentially the same table copied that we saw in the MindTap. So the same table here. You can grab the data file to open it up. And what we did is I created the returns just like we did in the previous spreadsheet: R1, R2, R3, R4, and R5, D1, D2, D3, D4, and D5. Okay, so for percentage invested, I took each of the categories and I added them up so their sum would be 1. You know, normally these are representing our variables, and we would just start out with initial values of, say, like 1 for each one. However, we want to make sure that we're investing only 100% of our money. That's going to be one of our constraints in the problem. And how do I calculate the R1? Well, what we do for the R1 is we want to multiply each of the first 6 categories by the percentage I'm investing in each one. So the R1 should be the sum product of these 6 with these 6, and that'll give me R1. Then for R2, I'm going to do the sum product of this array times this array. And what it does is it just multiplies 13.12 times 0.1 plus 3.25 times 0.1, and so on until the last value. You just need to be careful to not use the S&P row. If you do, you'll probably get some kind of error because you'll be multiplying a array that has 7 elements with an array that only has 6 elements. So let's take a look at the formulas. So the way I've got it set up, that you'll see sum product of B2 through B7, these 6 with B11 through B16, these 6. To do R2, I've got this 6 times this 6. Notice the blue array times the red array. R3, I'm doing year 3 array times this array. Year 4, same thing. And year 5, same thing. So the differences now, how do I compute the differences? Well, the differences, I'm just taking the S&P value and subtracting the R value. And I'm doing that for all 5. Subtracting C8 from B21, D8 from B22, E8 from B23, and F8 from B24. Just subtracting the S&P return in that year with our projected return from that year based on the percentage invested. And then the sum of the squares is the function that we actually want to minimize. So what that is that's just this cell squared plus this cell squared plus this cell squared plus this plus this. D1 squared plus D2 squared plus D3 squared and so on. Remember, that is the formula that we have on MindTap. This formula that we're trying to minimize. Minimize the sum of all the squares. So let's take a look at and then a total return is the average. That's the same as the previous problem, but we don't actually make use of that. So let's run the solver and see how we're going to get the optimized values. So we go to data, we hit solver, and we want to minimize the sum of the squares by changing our variable cells, B11 through B16, subject to the constraint that we want the sum, oops, I was in the wrong thing. I think I've done something wrong here. I think that'll work. Subject to the constraint that the sum is equal to 1. If we were allowed to invest more than 100% of our money, then I'm sure we could make a lot more. But we're limited to 100% of our funds. So we add that constraint that the sum value of all of the variables needs to be 1. And then we want to make sure all the variables are also non-negative, so keep the box checked and then do the nonlinear regression. Click solve, and we get a solution. So let's compare that solution. Let's try and work it into MindTap. So again, we need to turn these into decimals. So 30.33, 0, 0, 36.50, 22.65. And again, yours are probably different numbers. 10.52. Let's see how that worked. So check the work. Okay, so we got the values. The bottom two didn't work. Often they're just rounded up or down one more. So 22.66, I think that should be. And then this one should be 5.1. So that's actually my fault. I just rounded incorrectly. Yeah, and there we have it. That's the model, and that's how you do this one by minimizing the distance. Essentially, what you're doing is you're saying, I want to build a portfolio that is as close to the S&P return as possible, given the portfolio choices that I have. So that if you have a retirement and you manage it on your own, you might consider maybe trying to look at something like this. It would be a fun little real-life practice of this exercise. Okay, so hopefully that helped, and good luck on the final module.